Gravity's connection to thermodynamics. Look up at the night sky. What do you see? The silent, majestic dance of planets, the relentless pull of the moon on our tides, the terrifying, beautiful grip of a black hole from which not even light can escape. For centuries, we've called this force gravity, and we've thought of it as the great architect of the cosmos, a silent, geometric sculptor carving out the paths of worlds through the empty canvas of space. But what if I told you that this story is incomplete? What if gravity isn't a fundamental force at its core, but something else? Something emergent, like a wave rising from the ocean, only to fall back again. What if the true secret of gravity is written not in the language of geometry, but in the older, more primal language of heat, disorder, and information? Today, we are going on a journey to the very edge of known physics, to explore a connection so profound, so magical, it redefines our place in the universe. This is the story of gravity's hidden connection to thermodynamics. Let's start with something familiar: heat. In the 19th century, we discovered the laws of thermodynamics. They are the rules that govern energy, work, and the inevitable slide of all things towards disorder. The most famous of these is the second law: entropy always increases. Entropy is a measure of disorder, of randomness. A hot cup of coffee cools down in a cold room, not the other way around. Its heat, its energy dissipates, spreading out, increasing the universe's entropy. It's a one-way street. This is the arrow of time itself. For a long time, we kept these ideas in a box. Thermodynamics was for engines, for chemistry, for things here on Earth. Gravity was for the heavens. They lived in separate kingdoms. But then, a man named Jacob Bekenstein, a young graduate student, and a giant of physics, Stephen Hawking, shattered that wall forever. Their subject? The most gravitational object imaginable: a black hole. A black hole is gravity's ultimate victory, a place where space and time are so warped they are torn apart. Common sense would say that if you throw something into a black hole, a book, a star, the entire encyclopedia of human knowledge, it is gone, vanished from our universe. Its information is destroyed. But here's the problem. Thermodynamics tells us that information cannot be truly destroyed. It can be scrambled, hidden, made incredibly difficult to read, but it must, in some form, persist. This created a paradox. The black hole was violating a sacred principle. Bekenstein made a breathtakingly bold proposal. What if, he asked, a black hole has entropy, a tremendous amount of it? He suggested that the entropy of a black hole is proportional to the surface area of its event horizon. That point of no return. Think about that. Not its volume, but its surface area. This was insane. Entropy was a measure of the number of ways you can rearrange the inside of a system. How could it be related to the surface? Then, Hawking dropped the bombshell. He proved that black holes aren't actually black. Because of quantum effects, they glow. They have a temperature. They radiate. They are, in a sense, hot. This is Hawking radiation. This was the link. A black hole, the embodiment of pure gravity, obeys the laws of thermodynamics. It has temperature. It has entropy. It evolves. It can even, over eons, evaporate and die. Gravity was not separate from the world of heat and information. It was deeply, fundamentally intertwined with it. But how? What does it mean? This is where the magic truly begins. The work of physicists like Ted Jacobson took this connection and pushed it to its logical and mind-bending conclusion. He showed something incredible. If you assume that every single patch of space-time, every tiny little piece of our universe, obeys the first law of thermodynamics, the law of energy conservation, then Einstein's equations for gravity naturally emerge. They are not the starting point, they are the consequence. Let me say that again. The force that holds galaxies together, that sculpts the cosmos, that gives us weight, may not be a primary force at all. It may be an emergent phenomenon. It may be a side effect of the universe's relentless drive towards higher entropy. Think of it like this. Imagine the fabric of space-time is like this still pond. We see the water, we see the reflections. That's our classical reality. Now, zoom in, closer, closer still, until you see the molecules of water jiggling and vibrating in a frantic, chaotic dance. This is the microscopic reality, the world of quantum information and energy. Now step back. From this chaotic, statistical dance of countless microscopic parts, a large-scale property emerges. The smooth, cohesive surface of the water. It has properties, surface tension, waves, that you could never predict by looking at a single water molecule. Gravity, according to this radical view, is like that surface tension. It's not a fundamental ingredient of the microscopic world. It is a collective behavior. It is what happens when the fundamental bits of information, the ones that make up reality itself, interact in a way that maximizes entropy. Space itself is not a static stage. It is a dynamic thermal system, and gravity is its heat. This leads us to the most profound, the most holographic idea of all. If the entropy of a black hole is proportional to its surface area, then perhaps all the information needed to describe everything inside the black hole is somehow encoded on its surface, on the event horizon. The three-dimensional interior is a projection of a two-dimensional reality. Now take that idea and apply it to the entire universe. This is the holographic principle. It suggests that our reality, this vast, three-dimensional, seemingly solid universe of stars, planets, and us, might be a projection, a cosmic hologram. The true reality, the source code of the universe, exists on a distant, two-dimensional surface that surrounds us. We are the illusion, a very persistent, very convincing one, but an illusion nonetheless. Everything you see, every person you love, every star in the sky is a manifestation of information etched on the boundary of our cosmic horizon. Gravity is the force that emerges from the quantum entanglement of those bits of information on that boundary. It is the universe's way of maintaining consistency between the holographic projection and its source. This is not just philosophy. This is a serious, cutting-edge framework in theoretical physics. It connects the infinitely large to the infinitely small. It tells us that the fall of an apple and the glow of a black hole are two expressions of the same deep thermodynamic truth. So, what does this mean for us? For our understanding of reality, it means the universe is far stranger, far more interconnected, and far more magical than we ever dreamed. We are not just living in a universe, we are an expression of it. The warmth you feel on your skin from the sun is intimately linked through this chain of ideas to the very gravity that holds you to the ground. The arrow of time, the expansion of the cosmos, the very fact that you have a past and a future may all be emergent properties of this cosmic tendency towards disorder. We are witnessing the dawn of a new scientific paradigm, one where the lines between force and phenomenon, between the fundamental and the emergent, are blurring into oblivion. We are discovering that at the heart of reality lies not a set of cold, mechanical equations, but a dynamic, living process of information and energy. A cosmic computation whose output is space, time, and the force we call gravity. The universe is not a clockwork mechanism. It is a living, breathing, thermal engine, and we are all part of its beautiful, entropic dance. If this journey to the edge of physics captivated you, if you felt that sense of wonder, then do me a favor. Like this video, it truly helps the channel grow. Subscribe to the channel and hit the notification bell, because we delve deep into these mysteries every single week. And I am desperate to know what you think. Does this idea of an emergent, holographic reality resonate with you? What feels magical, or perhaps unsettling, about it? Let's start a conversation in the comments below. And if your curiosity is truly ignited and you want to go much, much deeper down this rabbit hole, I have something for you. I've spent years exploring these concepts in my book, Holographic Multiverse. We explore not just gravity and thermodynamics, but what the holographic principle means for consciousness, for the nature of reality, and for the possibility of other universes. It's a wild ride. The link to check out Holographic Multiverse is in the video description below. Thank you for watching. Remember to look up at the stars, but never forget that the greatest mystery might be the space between them. See you in the next video.